Right. Right. So, like I said earlier, this is an introductory course to data science. This is just to prep you, to psych you up for what is to come when you start the program on Monday. We're going to have two sessions, that is today and tomorrow. So today we're going to look at some basics and some fundamental concepts that underpin the concept of data science. And then we also do some installations and delve into some of the codes, explore some of the tools that we'll be using as data scientists. Now, a bit about myself. Right. My name is Prince Samuel Tremantin, and I'm in MPhil year 2. I've been a teaching assistant for 2 years. I think the coming academic year will be my third year as a teaching assistant. I've been working under Professor Yakuma Winfred. He introduced a course just a few minutes back. Um, I've learned a lot from Prof. He's given me a lot of opportunities to hone my teaching and research skills, and I'm forever grateful to him for the opportunity. Professionally, I am a software developer. I write a lot of software, all kinds of softwares, mobile apps, and all that. I also do some agentic stuff. That's like I build AI agents and incorporate them into the software workflow. If you want to get in touch, you can reach me on the number or send me an email. Prof is a very busy man, so I wouldn't want you to trouble him a lot. If you need something, you can pass through me first, and then I'll relay it to him as soon as possible. All right. So now that we have the introduction and the pleasantries out of the way, let's dive into it. Let's do some kind of warm up, right? And please also note that this class is going to be as interactive as possible. This is a master's program, and one of the differences between a master's program and undergrad program is that master's program you have a lot of chance to contribute and discuss in class. I mean that is Prof's one of Prof's key methodologies of teaching in a class. You do a lot of discussion. So please, anytime a question is posed, do as much as possible as you can to answer some of the questions. Also ask questions. Your colleagues will help you. If I can't answer, of course, Prof is here to help us all answer the questions so that we can all learn. Right, so let's do a quick warm up. What is data science? I mean, anytime you hear data science, what comes to your mind? You don't have to give an expert answer. I mean, maybe you did a quick Google search, maybe you heard someone say something, or even watch some YouTube videos. What is data science? What comes to your mind? It can be a word, a sentence, anything. You can raise your hand and just tell us. I don't know if I will see someone raising their hand because I'm sharing my screen. So if there is any hand up, you can unmute and talk. What comes to your mind if you hear data science?
Statistics and graphs.
Good evening.
Yes, good
Uh,
evening.
yeah, so I wanted to answer.
Right. You can go ahead.
Data science sounds to me like data, getting insights from data, trying
Okay.
numbers to give meanings to numbers.
Right. Right. The insight from data, meaning to numbers. Right. Thank you very much. Yeah, Asante, I see your hand up.
Yeah, can you hear me?
Yes, sir, I can hear you.
Okay, so basically, it deals with making inferences from textual data, images, audio, and vision or videos.
Right, right. Thank you very much. So making inferences from textual data, audios, and videos. Thank you very much, Mr. Yao. Anyone else? Data science, what comes to your mind? Let's take one more person so that we continue. I mean, you applied for the program, so surely you did some kind of research before coming. Yes, Ivan.
I think it comprises statistics and the like.
Please come again.
Statistics.
Statistics. Okay. Statistics. Right. Now, everything you all said is not far from the truth. It's actually right, right? Now you're going to have some kind of insight, some kind of meaning. There's going to be inference, there's going to be statistics. These are all terms that you will hear as we progress deeper into the course. Now, before we go into what data science really is, let's just play around the term a bit, right? Let's find out why we need data science, why data science is relevant these days. Now, you will bear with me that in this generation, in our current dispensation, data is everywhere, right? Now, everywhere you pass, you are sure to find some kind of data, either already collected down or in the generation process, right? Now, as a matter of fact, this class that is ongoing right now, we are generating tons of data, okay? So everything I am saying is data. Someone mentioned audio data, someone mentioned textual data. Now, these are all data that we are generating at the moment, okay? But then the truth is that anytime data is generated in its raw form, just like I'm speaking right now, okay, it doesn't really give us a lot of meaning or insight, okay? It gives us just some crude meaning. But then what happens if we want to dig deeper and find much more actionable insight from the raw data, okay? Now, that is why we need the concept of data science, because it helps us to transform these vast amounts of raw data that we are generating day in, day out into actionable insights, right? And then these insights will ensure that we make better decisions, okay? And when better decisions are made in the industry or academia or whichever institution is making this better decision, it's consequently will lead to improved efficiency in at large in the company. I hope that makes sense so far.
Yes, please.
Yes.
Right. And of course, on top of that, there is a high demand for data scientists. As I said, that data is all around us, and everyone is trying to draw insight from the data or the information that they have accumulated down. So it's in high demand. Your decision to do this course is not a bad decision at all, because you'll be in a very good place once you are done with the program. Now, let's also look at some of the real world applications of data science before we even look at the scientific meaning of data science. Now, sometimes when we introduce a course like this, people think it is too far, it is so far from us that we can't even relate. We don't know what is going on behind the scenes, right? And so I pulled just 3 examples here, and these examples heavily depend on data science. Okay, and I'm pretty sure we've all used Netflix before. Now, when you watch Netflix, when you open 3 different profiles, you are most likely going to see different movies for each profile. Okay, even in the same Netflix account with different profiles, you will see different movie suggestions for the different profiles that you have on your Netflix account. And this is because under the hood, they are using data science, okay? All the clicks you are clicking, all the likes you are liking, the watching, they study how often you watch this genre of movie, this category, and so on. And then they deduce that insights from the data that you have generated by using your profile. And then they use it to recommend or predict the movies that you are likely to like or to watch. Okay, so that is how Netflix recommendations work. It is heavily dependent on data science. So if you have used data science here before, it means that you have actually used some data science. Okay. Now, another popular example is Uber. Okay, Uber, I'm pretty sure everyone here has used an Uber at least once in their life, in their lifetime, right? And when you sit in an Uber, it's able to estimate, give you an estimated arrival time, okay? Tell you that when you start the journey, say 5:20 now, you should be able to get to your destination at exactly 6:10 p.m. And under the hood, it is using some predictive models or algorithms to be able to tell you, depending on some of the trips that have already happened, and then use it to calculate the estimated arrival time for you. It also uses the same data science concept to calculate the pricing, right? Now, you notice that in Uber, the pricing changes, slightly changes, right? It's because it is not a fixed price, it is an estimated price, and it uses data science to estimate this price for you. Now, in the field of healthcare too, data science is also used heavily, right? We can use it to predict disease outbreaks. Now, you recall that during the corona outbreak, when they come out to give us the corona cases, sometimes they tell you total recorded cases 10,050, and then it is estimated to reach so and so and so by June or by July. You remember that? That is all running on the concept of data science. Someone sat down to analyze the data, and then they were able to make inferences, okay, or they were able to make deductions or predictions that, looking at how it is going at this point in time, this outbreak is going to reach it. They can also tell you that, okay, looking at how the corona case is rising from Accra, in maybe 3 weeks' time, it will reach Kumasi. That is also predictive data science, right? Now, can anyone give us any other example, a day-to-day example that we all know that uses data science? You can just raise your hand and tell us. Anyone? Right, I see Lincoln.
All right, an example is YouTube. The videos you watch on YouTube,
Right,
there's an algorithm behind that monitors and then gives you predicted
right,
videos that you might be interested in.
right. That's a very relatable example. Thank you very much, Lincoln.
Hello.
Yes, Isaac.
Yeah, hello.
I can hear you, but I don't see who is talking.
It's Felix. It's Felix.
Okay, Felix.
Weather forecast.
Weather forecast. That's a very popular one. Weather forecast. Thank you very much. Isaac Agbesi. Isaac, if you can hear me, kindly unmute and talk. Okay, seems Isaac is coming in. Yeah, can you unmute and talk?
Okay, another example is when you visit a particular sales website and eventually all manner of items are associated with you using association rule and all that.
So that's e-commerce systems. That's a very popular one. Yes, I mean you go there today, you buy a mobile phone. Tomorrow you see that the mobile phones are chasing you
a
on
whole
the
lot.
website. Yes, that's very true. Thank you very much. Let's take one from Julius and another one from Felix. Then we can move on. Julius.
Yes. So AI systems like ChatGPT.
Okay, AI systems like ChatGPT. So in data science, we will get there when we get to the point where we are breaking data science and we see that it has a bit of AI in the artificial intelligence in there. So thank you very much. Yes, Felix.
That is inflation.
Come again.
I said statistical service.
Is it just me or we can't hear Felix?
No, I said inflation.
Inflation. Oh,
Yeah.
okay. Are you a politician?
No, please.
Okay, all right, that's just what I'm doing. Right, thank you very much. Inflation. So they calculate. So now I still don't know how they calculate that thing. But they do their own data science under the hoods, and then I'm sure several variables goes into it. And then they're able to come up with some kind of predictions to tell us that we'll have these inflations as well. So if you don't take care. Yes. Thank you very much, Felix. Thank you very much, everyone that contributed. Okay. Now we can move on to. Is someone talking?
Yes, sir. Mr. Prince, I had light off. I just came online.
Sorry.
Yes, sir.
Okay. So I'm pretty sure you head up to this slide. Okay, so we are saying that data science is not too far from us as individuals. In our day-to-day activities, we almost always use a bit of data science in everything that we do, especially now that we are all online. And one of the key examples that came up is Netflix recommendations. You realize that when you watch a movie, if you're like me, you like a lot of killing movies and investigations, you come to my profile and a lot of FBI movies, CIA movies, and magic movies and all that are there. But if you're like someone who only likes Korean movies, you will only see Korean movies. And that is because they are using data science under the hoods. And as you click on one movie, second movie, third movie, and they realize that the trend is all Korean movie, the next suggestion they will give you is a Korean movie. So Netflix heavily runs on data science. And then we also cited an example of Uber, where they use data science to be able to estimate your arrival time, as well as the price or the amount you have to pay once you get to your destination. And we also did for healthcare, where they can use data science or is heavily used to predict disease outbreaks, right? And then to also for personalized treatment plans, right? Now we'll look at all this. If we will ever meet in the main courses, we will do some of these hardcore practical projects, and you build some of these models to make some of these predictions. It's not going to be a theoretical course, it's going to be a very practical one, right? Okay, so now that we have, yes. Go ahead.
More examples. I said more examples.
You want to give an example? Okay, go ahead.
Yes. So election results from the Electoral Commission.
How does that work?
Okay, so for instance, as people go into the polls to give estimated results based on an upcoming election, it is based on previous data that informs them about what will happen in the upcoming elections.
Okay.
Do you get that?
Yes. I think that is very true. Now it reminds me, I think last year's election, not just last year, election headquarters. Is that the name? Is it TV3?
Yes, election headquarters.
Exactly. So they have that big screen, then they did some projections. Okay, based on the previous election, we project that this will come this way. That is all running on data science, okay? So when you hear data science, don't be scared. It is not something that is too far from you. It's something that is so close to you. And we are all using data science each and every day. Thank you very much for the example. So now let's come to the scientific definition of data science, right? I know some people may get jittery because we didn't define data science before we started looking at what it is used for and all that. I didn't want to go the traditional way, where you have to memorize some definitions before you even get to understand what it means. Let's understand what it means. And then even if you forget the definition, you'll be able to deduce it. That's what Prof taught me. Right. Now, I'm going to read from the slide. It says that data science is the study of data to gain knowledge and extract insight for making informed decisions and predictions. Now, you see that the key terms in this definition are all the things that those who spoke earlier, when I asked you what comes to your mind when you hear data science, you all mentioned some of these key terms. Someone mentioned insight, someone mentioned decision, someone mentioned inference, and all of that. These are all things that, or terminologies that come together to form the concept of data science. And we are saying that data science is like what I call an academic chimera. It is made up of several parts of different fields, okay? So you will find a bit of mathematics in data science, you'll find a bit of statistics in data science, you find a bit of computer science in data science, artificial intelligence in data science. And then the key goal here is that we are using a combination of all these fields to analyze large data sets and to transform the raw information that we have in the form of data into strategic solutions, right? So we have several fields that comes together to form data science. And as the course goes on, they will teach you some of the, in fact, ourselves will look at some of the statistical and computer science terminologies that may come up. Felix, do you have a question? Okay, I think it was a mistake.
Sorry.
Okay, sure. Right. Now let's move on. Now let's also look at, go to my screen. Let's also look at some of the roles in the data ecosystem. So anytime you hear data, we are talking about data science because we are going to study the data using all those fields that we spoke about earlier. Now, if you study data science or if you remain in the data ecosystem, what are some of the roles that you can work in? Okay, and what are the typical responsibilities that these roles play? And the first thing that will come to mind is the data scientist. Of course, once you are studying data science, you may call yourself a data scientist. And as a data scientist, what do? Your primary goal is to analyze complex data, right? And to develop models, right? We'll look at how to develop models later on in the program. And then how to use statistical methods to extract insights and then predict future trends. As a data scientist, that is all. Just one sentence. It summarizes everything that you do as a data scientist. But once we break these concepts down, each item identified in there goes deeper. Okay, so we'll brush on some of them, and then once the program goes on, you delve deeper into some of them. Then we also have the data engineer. So the data engineer, your job is to build and maintain robust data pipelines and infrastructure. Does anyone know what a data pipeline is? Data pipeline. Right, Mr. Yao.
Yeah, so it's all the processes from the acquisition of the data through data wrangling, the modeling, and maybe estimation and making inferences.
Thank you very much, Prince.
Oh, fundamentally, he has said it all. The various sources where we get the data for boosting.
Okay, all right. Thank you very much. So that is that. Look at data science don't look at it in a scientific way, something that is so huge that you can't understand. No, just look at it, break down the concepts, right? The terminologies in there. Most of them are just literal to understand. Now, a data pipeline, right? Just like Yao and Prince mentioned earlier, it involves the processes, okay, that you take to acquire data from one or more sources, right? You transform that data and then you move it to the final destination. That is a data pipeline. Acquire the data from different sources, transform them somehow, and then move them to a final destination. So data that is generated is usually generated from different sources, but then you want to work with that data as one. Okay, that is where data pipeline becomes useful, and the infrastructure. So Prof will be taking you through a concept like data warehousing, right, and data lakes and so on. I think in distributed systems or databases also one of them, right? So look at the practical use case of a data pipeline. But I think before this OPC session ends tomorrow, either we will build one data pipeline, or we'll give it to you as an example assignment that you go and do and come and present later on. We also have the ML engineer, the machine learning engineer. Now, when you study in the data ecosystem, you can become a machine learning engineer. You design, build, and deploy machine learning models, okay? You design the models, you build it, and then you deploy. I mean, when you build a model, no one is going to take your terminal and run the model in your terminal. It needs to be deployed so that the ordinary Ghanaian can use the model through a usable interface. Just like someone is saying that, mentioning something like a e-commerce site running on a data science model. Yes, that is an interface that you and I understand. So you should also be able to integrate it into something that the ordinary user can use. Then we have the data analyst. Of late, I see a lot of data analyst roles, especially on LinkedIn. And as a data analyst, if I'm to explain what a data analyst does in 2 words, it is interprets data. So you interpret the data. Now, data to me has a lot of similitude to law. Okay, you can read a law document and you read English, but it is actually not English. You need someone who is well versed in law to interpret the law to you. When it comes to data, it is the same. I mean, you may see the data as text, as audio, but you don't really understand what all this chaff is telling us. So you need someone who is well versed in the data ecosystem to be able to analyze it and then interpret it for you. Now, under this role, you have things like visualization. Okay, you do a course called data visualization in your first semester. Yes, I think starting from Monday. And here they will teach you how to, when you have your data, what are the different techniques in visualizing your data, which data is suited for which chart, which graph, and how do you prepare your PowerPoint slide or whichever slide that makes it very appealing to whichever audience you are presenting to. That is the role of a data analyst. Yes, so I'm pretty sure some of you have started telling yourself, okay, I want to be this one. Right. So any more examples, anything you can think of aside these 4 that we have here? Mind you, there are more. There are way more than this. Any more examples? What are some of the roles in the data ecosystem? Yes, anyone?
An AI engineer.
An AI engineer. Can you throw more light on it?
Let me just say you are more focused on artificial intelligence.
Okay.
It's going more into detail in terms of machine learning, but going more into detail.
Okay, all right. So it's just like the ML engineer, just that the difference between ML and AI is that AI is much broader than ML. The ML is just a branch of AI that focuses on the use of data to make predictions. There are other parts of AI that we can also think of. Right, thank you for the contribution. Right, so we can move on. Or do you have any question up to this point?
Yeah, I want to ask, what about data miners?
Right. I was expecting someone to say that. So can you tell us a bit about data mining? Data mining. Yes, Mr. Asante.
So they usually extract all manner of data, structured or unstructured, maybe using web scraping, and natural language, all manner of sources, both structured and unstructured data for the data wrangler to, clean them before extractions are done.
Right. Yes, that's good. So data mining. Now, just break the things. We have data. You already know what data is. Then we have mining. What does mining mean? To dig for precious minerals, right? So here you are digging for insights. So it's everything that we have explained here. Data mining, you dig for useful insight from the data, and you are going to use most of the concepts that we have already mentioned, right? So it's very close to data analyst, it's very close to ML engineer, it's very close to data engineer, close to data scientist, because they use similar tools across board, right? Thank you very much for the contribution. Right, now let's look at the data science workflow. Now, before you can solve any data science problem, you basically go through about 8 different processes. For all the rows, you most definitely go through all of these, or at least 5 of these steps to achieve your goals. And I'm going to pick them one by one and look at what it entails. Now, the first thing you do as a data scientist is that you have to define your problem. Now, what I mean by define problem is that tell us the scope of what you want to do. What are your objectives? Okay, what is the core objective that you want to achieve at the end of the code or the model you are building? Okay, it should be one objective. So something like, I want to predict customer churn, okay, or customer churn prediction. Now I've defined a problem. Now customer churn is, we are trying to analyze and study or predict which customers will stop using which vendors. That is customer churn. Okay, so in that way you have defined your problem. Okay, so as a data scientist, I can say, okay, my problem definition is to predict customer churn. Okay, that is the problem definition. It is specific and the scope is defined. Now, the second step to go through as a data scientist is the data collection phase or step. Now, after you have defined your problem, you need data. Don't forget, the whole concept of data science is hinged on one word, data. Okay, without data, there is no data science. You can't do anything without data. Okay, just like the soldier is nothing without their ammunitions. As a data scientist, without data, there is nothing for you to interpret. Okay, so you need to now go and find the data that will help you achieve your objective. So if I said my problem is customer churn prediction, then I need data that is related to customers and vendors. Okay, I need a data set that can tell me how many times customers patronize a particular vendor, and what are the products they buy, their age group, the demographics, and all of that. And all of these come together to form a huge data set that I can deduce or get insight from to help me predict customer churn. Now, the third one, which is one of the very, very important steps in the workflow, is data cleaning. Now, as a data scientist, you are going to be building several models, okay? In your entire life, you build a lot of several models, but one thing that you have to take note, if you don't learn anything from this OPC today's session, note this, that every model is just as good as the data you feed it, okay? Every model is just as good as the data you feed it. So you are very familiar with the concept of garbage in, garbage out, right? So if your data is garbage and you put it in to train your model is going to give garbage response, okay? So once you're able to collect your data, it is now time for you to clean that data. And there are several things when it comes to data cleaning that you can do, okay? But some of the most common ones that you'll be dealing with is missing data. And missing data is actually my field of expertise for my MPhil. I'm studying how to impute missing values. Now, missing value is when we have a large data set, but some of the values are missing. And you can't go ahead and just train your model with that data set with all those potholes in there. So you need to find a way to treat all those potholes, okay? And there are a couple of approaches that people have come up with to address this. And as study goes on, we eventually get to learn some of them. We also have inconsistencies. So for instance, you find your data set and the one of the columns is telling you age, but then age, you find someone writing a name or a telephone number there. That is an inconsistent column, okay? Because the rule of data is that if you have a column, the column should have, or the values in the column should belong to the same domain. The same domain means that the values should fall within the same range. So if it is numbers, it should be numbers. If it is text, it should be text. That is one rule of thumb for a good data exploration. We also have errors. They can come in several forms. Now we have the EDA, which is a very useful tool that helps us to understand the data sets when we get it for the first time. So it's called exploratory data analysis. So here we try to do some visualizations to uncover some patterns. So if I give you a very large data set, how do you even know what to do with it? Okay, so through the exploratory data analysis, you're able to get a glimpse of what the data is. So you can tell, are there outliers, how many rows, how many columns, what are the various averages and the percentiles that we have. So you can do all this exploratory data analysis on your data set to give you some first-hand insights from the data. Now, once we have done all of this, we now move to the modeling stage. So this is where you now use appropriate algorithms to build either your predictive or your descriptive models, right? Now, when we come to building models, there are several algorithms that have already been done for you. So technically, you are not now going to build the models. You are going to be training the algorithms on a set of data sets, and then you'll be doing things like parameter fine-tuning and hyperparameter fine-tuning to keep your algorithm in a way that makes it suitable to make the predictions that you are looking for. And the data sets, as well as several other factors, will determine what kind of algorithm you should use. That's why when you check the slide, I wrote appropriate algorithms. So not every algorithm can be used on every data set. Now, after building your models, you don't just build a model and leave it in a vacuum. Or you just build a model and then we take your word for it that, oh, the model is good. No, you have to evaluate the model and tell us, okay, you have to evaluate the model using some evaluation metrics. Okay, as time goes on, you'll be exposed to things like the mean squared error, the normalized mean square error. You'll be seeing things like the F1, the precision score, and all of that. Okay, you will see all of these evaluation metrics, and they help you determine how accurate your model is. Now, after you have done all of this, built your model, done the evaluation, you don't throw the model away or you don't keep it on your laptop. I mean, who else is going to use it? So you have to deploy your model, okay? You have to deploy your model either by building some kind of system on top of it or some kind of application on top of it, or you put it in anything that will give someone else the chance to use the model, okay? Because I don't think you want to waste your time to build a model that no one will use. Yeah, so once you build a model, you have to deploy the model. Now, one other very important concept is the communication phase. Most likely than not, you are going to build your model, and so for those of you already working in companies, after this program, they are probably going to make you the head of IT or something, right? Or head in charge of data science, right? And you'll be building some of these models and you'll be showing it will be on you to show it to management, okay, or investors. Show them how good your model is performing. This is where things like data visualization comes in. You have to visualize your insights clearly, okay, and targeted, because there are some charts that are suited for different kind of audience, okay, compared to other charts. When you use a chart like a pie chart or a bar chart, I mean, it's easy for even a layman to understand. But when you start using things like violin plots with confusion, not confusion, yeah, even confusion matrix can be plotted. Confusion matrix and all of that. I mean, not everyone understands all that. Okay, when you start doing confidence intervals, and I mean, not everyone understands all those. Even the box and whisker plot, not everyone understands that. So you know your audience, and then you present your findings in a way that suits your audience. Now, up to this point, are there any confusions? If you are confused, please speak up and then let's help each other understand the concepts better. Hello.
Thank you.
Hello.
Yeah.
Can anyone hear?
No.
Okay.
I think he's speaking, but I think
Is the network okay?
I believe so. But I have a question.
Right.
So Prince, for the data science workflow, I want to know where the medallion architecture falls in, because I've learned about that and I can't see where it is in any of these flows.
Right. Can you throw more light on what the medallion architecture is? What did you read?
So medallion architecture is actually used in data lake houses, and it is actually organizing your data into 3 distinct layers, which is the bronze, the silver layer, and the gold layer. So it is at first I thought it would be at the data collection layer, where so the bronze actually means like collecting the raw data. The silver layer talks about processing some of the data, and the gold layer is the final data. But all these comes in play when you are dealing with the ETL or the ELT, which you also did not mention any of that. So I want to know if that is a different branch, or it also falls under this, or it is an advanced level. I just want to, yeah.
So what you mentioned falls under what we said. Is someone still talking? Okay. So what you said falls under one of the rules that we explained earlier. Right, where we mentioned the data pipeline, the data engineer. So what you are mentioning, okay, is not a component. It is actually an application of the workflow. Does it make sense?
Okay.
Yes, it's an application of this entire workflow. That is why you yourself, you are saying, that's why you were saying that a part of it deals with data collection, a part of it deals with cleaning, and then a part of it is the actual data. Okay, so it is actually an application of the data science concept or workflow that we are looking at.
Oh, okay.
Mr. Chachu.
Yeah, so like I want to ask is this workflow, is it like static, or probably there may be something like might have been missing in the workflow, or like is this like generally that's what everybody uses, or because kind of like some stuffs are not really inside, so I just want to ask. Yeah.
Okay, so is this a workflow, right? Is there something to guide you, to show you that these are some of the steps that you usually find as a data scientist? I mean, there is no way a data scientist, you build something that you will not define your problem. I mean, if you don't define it, what are you building? There is no way you build your model without collecting data or getting data from anywhere. Okay, you won't build your model without doing data cleaning, else your model is not going to perform well. Now, as for EDA, you may choose to do it or not. Now, the reason why it is appropriate for you to do it is because it gives you first-hand insight from the data. Okay, and then after that, you are obviously going to build your model. You are obviously going to evaluate it. And then, of course, it's a good thing to deploy, right? Some people, not everyone may present the findings. Okay, you may do it and someone else will present the findings. So something like communication is also not compulsory. So the list here is not cast in stone. It is giving you a typical workflow that you find most people using. Okay, but it's not like compulsory, you have to use it this way. No, but some of the key things are in there that you cannot do without. I hope he answers the question. Hello.
Yeah, so yeah, like it's okay. Yeah, because I was actually thinking that I mean at a point you could stop at any point. So it's not every time
Right.
that you want to build a model or something.
Yes.
So you may want to end that somewhere. So that's what I'm asking.
Yes, that's very true. I mean, it's not all the time that you build a model, but most of the time you are actually going to build a model to do something. If you just want to clean the data, that's also, you use part of this, but you will not reach the modeling part. So that is also very true. Adolf. Hey, is it
Yes,
Hitler?
sir.
I hope you will not come and kill us.
No, it's not Hitler. All right, Prof. My question is, you mentioned assignment around data pipeline, and I want to give it a try. So I needed you to repeat the question.
Sorry, I will also need you to repeat your question. I didn't catch everything.
Mr. Prince,
Yes, I can hear you now.
I didn't hear you clearly.
I said, can you please take your question again?
Okay, so you mentioned an assignment that in the future you will be asking around data pipeline.
Okay.
And I'm saying, could you give it out now? I want to give it a try.
Are you asking that I give it out now?
Yes, boss.
Like people are energetic for the program. I like that. We will do it eventually. Okay. I'm pretty sure by the end of this program, this session, we will have that assignment. So we have a session for that. Does that answer you?
Yes, sir.
All right, thank you very much, Adolf. You are really showing you are Adolf. You want to do the impossible.
You, Prince.
I see. All right, thank you very much, Adolf. Please, any question before we move on? Any question, contribution? Yes, the guy that asked the question about the workflow, is that Solomon?
No, I have a different question.
No, I'm the
Okay.
one, like, yeah, Edward.
Okay,
Chachu,
so let Solomon finish, then Edward, you come in.
Okay. So my question is that I understand with the data science workflow, there has to be some model building somewhere at
Right.
the modeling phase with the application of appropriate algorithms for predictive analytics and other stuff.
Yeah.
Is it always the case that for every problem definition or every intelligent sort of problem definition, we need to apply an algorithm? Can we use a different?
Can you use a different word? Can anyone hear Solomon? Hello?
Hello?
Solomon, can you hear me?
Yeah, I can hear you.
I didn't hear the last part. He said, can we also use what?
Some form of like an if-else statement, right, to achieve some form of intelligence. Does every problem have to be wrapped around an algorithm? Right, that's basically the question.
Okay, I think I get what you mean. Now let me answer it this way. What is an algorithm? Can you tell us what an algorithm is? Or can anyone tell us what an algorithm is?
Okay, so I know in machine learning, it's a mathematical function that takes an input, then returns an output.
Okay, so now when we say an algorithm, it is just the stepwise process you take to complete a task. Okay, so even the if else you are saying is also an algorithm. Does it make sense?
Yeah.
Oh, I think Solomon's network is not. So that one is also an algorithm. But let me answer your question this way. I hope we are clear that that one is an algorithm. So let's come back to the main question. You remember someone contributed and asked a question that, do we always need to build the model? And we said no, it depends on what you are doing. But most data science tasks will require you to build a model. So maybe if what you are doing is just to clean the data and explore it, you don't need to build a model for that. Okay, you can use if-else statements to transform some of the data. Okay, so maybe you can use if-else statement to map maybe some kind of string to some int and so on. Do you get it? It depends on what you want to achieve. But I can promise you that maybe 90% of the time you'll be building a model, not using if-else statements. Because conditions they are not that simple, okay, for you to be able to model using just ordinary if-else statements. People have tried and they failed. That's how come we came up with modeling. Right.
Okay. So is there like a line, right? Or a point where you realize that, okay, for this problem, we can simply solve it. Like, when do you draw that line between just using an if-else that will work well and then trying to build a model with an algorithm?
I think that it depends on two things, right? The kind of data set you have and what you are trying to do. So you yourself, the moment you see this huge data set, you know that you cannot do an if-else statement. Other than that, your code file, you're going to have about 1 million lines of code, and that lines of code is just a if-else statement, right? So the moment you see that you can't use like 20 or 30 lines of code to do a particular thing, you have to know that the model is the best way to go.
Okay, all right, thank you.
All right. Mr. Yawasante.
Yeah, I think we should be clear on certain things. The modeling here seems to be creating problem, but I think we are going to use Python libraries.
Yes, that's what I said, that
Yeah, said that when we define our problem, maybe it's a classification problem or a problem that may need a service or a labeled data, then we have libraries and modules and class that we can just, invite from Python to solve our problems for us. So I don't think we are going to, actually write some codes for ourselves to do some of this magic. So maybe we should relax on some of these things.
Yes, I mean, I literally said this earlier, that you are technically not going to build the models. You are just going to train them on the existing algorithms, which is the libraries that you are talking about, right?
Yeah.
So yes, please, I understand. This is an introductory course, right? So let's calm down a bit. I know you are eager, you want to do that, and believe me, we will do for you. But this is the beginning. So let's not scare those who are not into data science off. But I really appreciate the contributions and the interactions. Let's keep it up, but in a moderate way.
Yes, don't scare us.
Is anyone here scared? Don't be scared. Don't be scared. Yes, Mr. Opoku Joseph.
Okay, so thank you very much.
Right.
So I wanted you to throw more light on something. The medallion architecture my colleague was talking about. I think one of my colleagues was talking about medallion architecture, where he was trying to link it to the data lakehouse and data warehouses, whereby he also introduced the ETL approach in it. So I'm trying to add more to it, that normally the medallion architecture is like the modern way we deal with data. But when you look at how data warehouses mostly comes from structured data, or data that are really structured. But when we look at the data lake houses, in most cases they come from different sources. Structured. So a typical example in practice, what we do is that maybe when you collect raw data about people, maybe sales made by a company, and you store that data, you can keep it in a warehouse. So a company can have that, maybe sales made by customers. Within a month, will be kept in the warehouse. That will be like, it's really structured data. But normally when you talk about the data, it can be unstructured, semi-structured, or structured one. Here you can look about maybe your customer relationship management tables, your JSON, and some videos, some live streams about the company, right? So the difference here is that normally when you talk about the warehouse, it's a bit structured. So when I'm dealing with sales, I want to know the sales trend in an organization, maybe Coca-Cola, within the past 2 years. Then I will have a structured data that I can extract. So I will use the ETL approach, extract, I will transform, and I will load the data, and I will work on it. It's really from live streams, data from recommendation videos, data from tweets, data from comments, different data from real life personalization. So when you have that, that one too is called data lakehouse. So because normally when you are doing that, we can't use the normal ETL approach because it's not really structured. We use the medallion architecture, whereby at the bronze level, it's the same thing, like whereby we look at the raw data. So raw data here, we are looking at different type of data. There's both the semi-structured. We can look at videos, the comments, and you know that comments will come in maybe words, narration, but maybe sales will come in numbers. So at the bronze level, we do we do that. We look at the raw data from that. Then when we move to the second level, because at the bronze level, we have different types of data, both structured, unstructured, semi-structured. We try to look at that data was there. And at the silver level too, we try to clean the data to standardize the data. Because here, we can only analyze it when we have a standardized data. We can only analyze it when we have a standardized data. So we can't analyze videos and numbers together. So we try to have a standardized data so that we can use it to do our analysis. And at the good level is where we do a lot of business intelligence. At the end of the day, a lot of business intelligence at the end of the day, right? So I'm a marketer, so that's what we do a bit too. Yeah, thank you. So I decided to share.
All right, thank you very much, Opoku. Okay, Dominic, come in before I take it. Dominic, I see your hand up. Is it a mistake?
Oh, sorry, I was talking while on mute. Can you hear me, please?
Yes, we can hear you now.
Okay, all right. So I'm just passing a comment.
Right.
All right. So I
Hello. Is it just me or we can't hear Dominic? Hello, Dominic.
And they are only trying to understand the basics.
Hello.
So some of the things. Yes, do you hear me, please?
Sorry, I don't know if you were the one that dropped or I dropped. I couldn't hear you from the moment you started.
Oh, okay. All right. I'm saying that my colleagues seem to be knowledgeable about the field, some of them, and are giving wonderful contributions and asking great questions. But then I feel we should also stick to the scope of the OPC, right? Because we also have people who are new to the field and are only trying to understand the basics. And some of these questions seem to be scaring those that also want to become, you understand? So I feel we should stick to this as an introductory course as it's supposed to be and help those that are also now up and coming to understand the basics.
Yeah.
The deep questions we are asking is going to confuse others and probably even bring down their morals. So this is just a contribution, please.
Right. Thank you very much. And the contribution is very important. Yes, let's try and be moderate in the kind of things we say, the questions and the answers, right? Now, I know some of you might have gotten a taste of data science before coming. Others are now coming. Some are even coming from fields that are not IT related, right? So let's try and tone it down a bit. Now, back to the answer for who gave is that Solomon? Who spoke before Dominic? Is it Solomon?
That was Joseph.
Okay, Joseph, right. Now, you remember when he asked that question, I told him that it is an application, what he's talking about is an application of the data science workflow concepts, right? And I even referred him to one of the courses that you'll be taking where you'll be going deeper into the data warehousing and data lake concepts, right? So here, hold on, just give me a second.
I think you are on mute. Oh. Yeah.
Hello, guys. Can you hear me?
Yes, we can hear you.
Yes. Sorry, I received a call. So, right. So, where was I? Yeah, I was trying to point out to you that this is an introductory course. That is why some of the concepts we don't want to go deeper into it now, because you'll be learning them at the advanced stage. Here, we just want people to have the very fundamental of the program. Okay. Now, all the big things you mentioned, when you look at it carefully, you realize that it has a bit of problem definition in there, a bit of data collection, a bit of data cleaning, a bit of EDA, a bit of modeling, a bit of evaluation, deployment, and so on. Okay, so these are all things that you build on to form all those big concepts that we are talking about. So thank you very much for the contributions. Let's move on. Or any question before we go? Okay, so if no questions, let's move on. But notwithstanding, this is not to discourage anyone from asking questions or answering questions. Yeah. Right, now let's look at, okay, so we already looked at the workflow. We've explained into detail some of the concepts in the workflow. And so let's pick, say, an example and then see if we can just oppose the examples and then do divide and conquer. Okay, break apart the examples and give the respective components to the various components of the workflow. So for instance, we are looking at the hospital no-show prediction, an example. Okay, so the hospital no-show is the patient who skip their medical appointment in the hospitals. That is the hospital no-show scenario. So assuming that this is something that we want to do, we want to break down the concept, make it practical for us to understand. How do we define the problem, or what's going to be the problem? Can anyone help us? I mean, it's quite simple. Some of the things are already on the slide. I just want to relate it to things that you understand. How do we define the problem? Or can someone come up with a problem definition? Yes, Akoli.
So are we defining the problem or like we are stating a problem?
Okay. What's the difference?
I have no idea. But I just wanted to if you are stating a problem, then I will state. If you are defining, let's be a little bit tweaked.
Okay, so whichever you are comfortable with, you can give us that.
Okay, yeah. So the problem here is that example, so we have an e-commerce website where people buy from that area, right? So at the end of the day, anytime they come and buy, we find it difficult to know what they want at every time. So we want to have a way to keep track of what they buy, recommend to them anytime they come on the platform again. So that is a problem identified. Now the problem is that building a recommendation system.
Come in. Sorry to cut. So the example, we are looking at a specific example, the hospital no-show prediction.
Oh, okay.
Yeah, so we are using the hospital scenario where patients miss their appointment with the medical experts.
Okay. Then I'll take it back. Someone can just go ahead.
Sure. Thank you very much. Can anyone help us? Right, Joseph. I hope it's fine if I call you Joe.
Yes, please.
Sure. Yes, I can hear you. Hello, Joseph, can you hear me? Julius, can you hear me? If you can hear me, can I unmute and talk?
Hello, please. Sorry, I had a network challenge.
Yes,
hello,
go
please.
ahead.
Can you hear me?
I can hear you now. You can go ahead.
Okay, so with the problem here is predicting patients no-show at the hospital to optimize scheduling. I think the hospital wants to identify in advance which maybe patient is more miss an appointment so that it can help them to reduce wasted schedules, because when patients don't show up, it means that some of the schedules they've done or time slot will be wasted. So they just want to make predictions to avoid some of these, to reduce some of these wasted time slots.
Okay. All right. Thank you very much. Now, when defining your problem, yes, I know he had to explain for us to understand, but for the purpose of documentation, it needs to be something brief, but also throws light to. It also explains what you are trying to do. So you see, what is here is actually a good example of the problem definition. Okay, so predicting patient no-shows at a hospital to optimize scheduling. You remember when we explained problem definition, we said that it tells you the objective and then the scope. Okay, what is your objective? To optimize scheduling, right? Knowing the no-shows and then optimizing the schedule, right? And the scope is in the hospital. So this is a good example, right? But because it is English, someone can come up with a different language, or a different sentence that also brings to bear the objectives and then the scope as stated here. So can anyone look at this and come up with a different definition for this?
Can I say hello? Can I say this?
Sure, you can.
Hello.
Yes, sir, I can hear you. You can go ahead.
Can I say forecasting patient no-show within the period of the year?
Okay, let's throw this back to the class. What do you think? What do you think about that definition?
Sorry, I didn't raise my hand for you to call me. Yeah, but I think what is missing is the why. Why are you doing it? What's the goal? What's the...
Okay, so can you correct what he said?
So probably forecasting the no-show for the year. So so as to, for example, minimize losses, or maybe come up with a better strategy or something.
Okay. Now, okay, yes, Joseph, you can go ahead.
Yeah, I think also look at it this way. What are the factors affecting patient to miss appointment with experts? A professional, medical expert.
Okay. Now, let me take this. You see, right from the moment of hearing that, we say it begs the question. Okay, it's open-ended, but don't forget we are saying that the problem definition has to be scoped. Okay, and it has to have a specific or a definitive objective that you want to achieve. Does that make sense?
Yes, boss.
Right. Yes, sir. Yes, I have something to say.
No, please.
Okay, all right. Thank you very much. Okay, let's take Solomon, the last one, then we go on.
Okay, so I have a question. The no-show means patients who do not come to the hospital, right?
Patients who will not come to the hospital.
Who will
So,
not
for instance, they've come already, they are supposed to come for an appointment.
but they won't come.
So those who have an appointment and they miss it, yeah.
Okay. And can we also look at it from the perspective of patients who will come? Like, since we want to optimize scheduling, so can we know how many will show up instead of trying to find out how many will not show up? Because I think if you know those who will not show up, it may not necessarily give us a clear picture of those who show up so that we can schedule appropriately. Or what do you think?
Yeah, that's interesting. I think you've started thinking like a data scientist, but the problem here is that we have a problem that we are trying to solve. Okay, so if you bury your head in the sand as if the problem does not exist, it won't solve this particular problem. I understand you may also do the other part of it to ensure optimal usage of your resources and all that. But at this point, we have a problem and we are trying to solve, which is the no-show. So how do we predict it? And then how do we predict it? Then how do we avoid it? Okay.
Can I proceed first?
Sure.
So, can we say reducing patients no-show by analyzing?
Sorry, I think you dropped for a while. Can you take it again?
Hello?
Yes, no, I can hear you now.
Hello?
Yes, I can hear you now. You can talk.
Okay, so I'm saying reducing patients no-show by analyzing the reasons why they don't.
Okay, now if you say analyzing the reasons why they don't come, it means that you already know the reasons why they don't come. You already have it. You are not just going to analyze it, which may not necessarily be the case. Okay, so let's do it this way. Let everyone go back and then try to.
Can I also try this?
Okay, let's take it as the last person. There we go.
Okay, so can I say detecting patient attendance to improve scheduling reliability?
Attendance is a bit general.
Okay.
Okay. Now I understand this is the first time for most of you, so that's fine. So what I want you to do is that go and ponder over this, okay? Then by tomorrow, come up with the problem definition for this thing that we are trying to do. Okay. So we have what is currently here now is predicting patient no-shows at a hospital to optimize scheduling. Okay, that is a problem definition now. Now remember we said that once you have your problem definition, you now need your data set. Okay, you now need to collect your data set to help you carry out the objective of your work, right? Now, what do you think are some of the data, or where do you think we'll get some of these data to achieve our objective? Hello?
The hospital.
Right.
Complete data from OPD.
Hospital's OPD. The hospital's OPD. That is the outward patient department, right?
Yeah.
So we'll get some data from this. So that is one source. That is a component of the hospital. And we'll get, don't forget, we also mentioned earlier that data may come from different sources. It is now your job to build the pipeline to integrate those the data that you get from different sources. So you get from OPD. Anywhere else we can get data from?
The hospital management system, their database.
Right. So if the hospital has a management system, of course, you can leverage on the data that comes from the management
You can
system.
also pick it from the hospital registry.
The hospital registry. Hospital registry.
You
Yeah,
can
You can
also
also
pick
pick
it
the
from
data from
patient's
the hospital
record.
registry.
For proper organization, let's try and raise our hands so that we don't cut each other. Okay, yeah, so the patient, the hospital's records and registry, of course, will get data from the Julius.
Probably some will know the call logs.
Some of
Phone call logs.
You can also collect data from.
Julius, I couldn't hear you.
Phone call logs.
So the hospital's phone call logs, eh?
Yes.
Yeah, I think that makes sense. That makes sense. Right. Thank you very much. And we'll get a lot of data from all those places that we are talking about. Now that you are given the data, for the first time, you'll be overwhelmed by the data because you won't know what to do with it until you now sit down, do proper exploratory analysis. Then you know how to go about merging the data that you have. Okay. Now, after collecting the data, you now have to do your data cleaning. Obviously, the data that you get is going to have a lot of missing records, a lot of inconsistent records in there, okay? And so it is now on you as a data scientist to clean this data. Now, there are several approaches you can use to clean the data. You have downsampling, where you drop some kind of rules that are undesirable to you. You can do imputation to fill the missing values, and so on. You can reformat, do normalization to clean the data, to make sure that the data is suitable for you to now use for your modeling. Okay. Then from there, you do your EDA. Now, if you are doing your EDA, what do you think are some of the things you would want to see? You can do something like what is that? No shows by day of the week. So you can plot a graph from Monday to Friday overall. How many people miss their appointments on Mondays? How many miss on Tuesdays? How many miss on Thursdays? Now, once you have that, why do we do that? The reason why you do that is because if you find out that most people are missing their appointment on Mondays but are coming for the appointment on Fridays, there could be a causative element there. It could be that it is not a patient, but it's actually the day, because everyone has to go to work on Monday. Okay, so when the hospital knows this, it now helps them to reschedule some of the appointments and bring them from Monday to maybe Friday to see if the people will now come to it. So that's the purpose of exploratory data analysis. From there, if you want to go ahead and build models, of course, you can go ahead, maybe use logistic regression, which is also one of the models that is quite used in data science, to do a prediction, okay, to check the likelihood of a patient having a no-show or a patient not coming for their appointment. Now, once you have done that, you have to evaluate your model's performance, okay? Now, I mentioned earlier that there are several metrics. We have accuracy, we have recall, F1 score, and all that. I mean, we may not go deeper into those ones yet, because this is just an introductory course, right? But as time goes on, you'll be introduced to some of them. Some of them, no one will even teach you. Yourself, you find them out on your own. And then, of course, we have the deployment. You now deploy it into the hospital's appointment booking application. So if the hospital has got an appointment booking software, then you liaise with them and integrate this model into the appointment booking system. And the moment they book the appointment, the predictive model should be able to capture that appointment, run it through the model, and tell if there's going to be a no-show or the patient will actually show up. Okay, good. Now, that will sum it up. But then most often there's going to be a communication element where you would have to present the management with some interactive dashboard that they will use to manage, and they will be able to see a forecast of the no-shows, right? And then through that interactive dashboard, they will be able to make some adjustment to their schedules. Now, I'm pretty sure that after going through all this process, even those of you who do not have IT backgrounds, you are gradually gaining some kind of confidence in the program. And it's not that difficult. Don't let any comment anyone pass to intimidate you. It is just as simple as we are looking at it. We'll build on it gradually. And as time goes on, you will become used to some of the terms that are popping up here and there. Okay. Now, let's look at some of the tools that you'll be using as a data scientist. Now, you will not be doing the data science in your head, right? You'll be using some tools to help you achieve your goal as a data scientist. Now, obviously, you will need a laptop or a PC, and then you also need some tools, okay? You will need Python for this course. Python is a programming language. I'm sure most of you have heard it before. Most of you have even programmed in it before. If you have, that is a very big plus. If you don't have, the good thing is that Python is very simple to learn. And you can use a week, you can dedicate a week to learn Python and you will learn it very well. We also have R, which is also a programming language of a sort, specifically for statistical computing. It was specifically made for data science, right? Things relating to statistics and then data science. As for Python, it is a general purpose programming language that you can use for many other things, AI, web, APIs, and so on, microservices, and so on. A lot of automations. Then we have SQL. So most of the companies already have their databases, right? And over half of the databases we have in the world is powered by SQL. But some people call it SQL. Somehow I prefer SQL. I don't know why. Yeah, but most people call it SQL. It is the standard or the de facto programming language. It's not a programming language per se. It's a query language for manipulating your relational databases. Right. So then we also have Jupyter. It's also one of the tools that we'll be using to write our codes and running our code, doing visualizations and so on. Of course, there's going to be version control as you write your code for modeling and then analyzing your data. You don't want to be losing the data every time and starting afresh every time. So you want to commit these codes to GitHub. So those of you who don't have GitHub, you may want to create an account on GitHub, maybe now or after the class. And then, of course, one of the libraries that you might not be able to do away with as a data scientist is Pandas. Pandas, it has powerful data structures and methods that will help you, will make this whole data science a breeze for you. And then, of course, we have scikit-learn, which is a machine learning library that will help you build or train machine learning models to handle classification or regression or clustering assignments. Yeah, so we'll look at we'll install some of them today, and then we will do some practice with some of them. Before we go on, can anyone confirm the time for the class? Is it a 2-hour class or a 3-hour class?
It's a 3-hour class, sir.
3 hours.
5 to 8.
5 to 8. Right, that's long.
Yes.
Okay. So, any question before we go on? I think I saw some hands up. Yes, right.
Yes, please. So I have a little problem with the Jupyter. So is it like a development environment or where we for the analysis or what?
Yes, Jupyter is an environment. It's more like an IDE for doing this stuff. But for the purpose of this OPC, we will be running the Jupyter in VS Code. We will not go and download the full-blown Jupyter Anaconda to run Jupyter. We'll be using VS Code for these exercises, and we'll just install the Jupyter extension. It's pretty easy and simple to use. If you know how to use it in VS Code, you may not want to go back to the main Anaconda and Jupyter stuff. Yes,
All
Eric.
right, sir. Thank you.
You're welcome, sir.
Okay, thank you, sir. I want to ask, is it good to only know the Python without knowing the R, or we have to learn the both?
You have to understand that as you are learning or you are taking this course, you are preparing yourself for the job market. And it will be best if you know the two. But I can also maybe say with a certain amount of guarantee or certainty that you'll be able to use Python to do almost everything, almost all the data analysis or the data science stuff that we want to do. But it's best if you know R as well. Gives you the edge over other applicants.
Okay, thank you very much.
Right. Philemon.
Hello, Prof. Please, may I know what kind of laptop you'll be using concerning the specifications, or any kind of laptop is available? Or yeah, that's what I want to know.
Okay, I think that at least for the tools I have on my screen here, you don't need too much. But if you have like a 16 gig PC, generally 16 gig RAM should help you. If it's an i7, that's great. But the minimum should be like an i5. The generation, if it is 10 plus, that's great. But a minimum should be an 8th gen. As for the operating system, it doesn't really matter. I am using Windows. I am on Windows. You can use a MacBook. That's fine. If you're a Linux person too, I think very few people are Linux people. You can also use Linux if you want, because all these tools are on all those operating systems. What you can't do is to say you want to use mobile phone for this program. For that one, I highly advise against that. You can't do that. So please, if you don't have a PC, I think it's a good time for you to start thinking of getting one before the going gets tough. But this program is going to be very practical. Yes, Eric. Eric, your hand is up. Okay, I think it was a mistake.
Hello, Prof. I think you did it.
Hello, Bright. Bright, can you hear me? Hello, Bright. Can anyone hear me?
Yes, Prof. We can hear you.
Okay, I think someone was asking a question. Bright was asking a question. I didn't hear him.
Yes, Prof. Please, I was talking about the last one. Please, you didn't explain the last one to us.
I'm coming. Before I come to your question, I am not Prof. Okay, I am not Prof. Prof is also in a meeting, but I am not Prof yet.
Yes, sir. Yes, sir.
Yes, don't give my boss's position, my boss's title to me yet.
Yes, sir. Yes, sir. Noted. When noted.
Right. Thank you very much. So you said that the last one. Which is the last one?
Scikit-learn or
Scikit-learn. Scikit-learn. Is that what you mean? This one? Hello.
Yes, Prince, that's what he means.
So scikit-learn is just a library. Okay, it has a lot of ML algorithms in there. So as you remember, I said earlier that you will not be building these models, you'll be training them. Okay, so scikit-learn has a lot of such algorithms or models that you'll be using to train your ML models. Okay, so it's a library. Right, any question before we go on?
Sir.
Any question? Okay, so if no question, let's move on to the next. I think we'll have to be doing some. Okay, so we'll be exploring the Jupyter Notebook interface and see how it looks like. But before we go there, let's look briefly at some of the things that we'll find. On a Jupyter Notebook, you are going to find some interactive cells. So there you can write, if you know Markdown, okay, you use some weird characters to structure how it should show. And then you can also write your code in there. You can write the Python or an R. You just have to select the kernel, which kernel you are using to run, and then you should be good to go. It has a very rich interface that will show you the codes as you are running it, and it will directly output. If the code has to output something, it will directly output it right underneath the code that is outputting it. So for you to know that, okay, this is the flow of data from my code, from here to here in my code. And then of course, once you write your Jupyter Notebook file, you'll be able to share it with colleagues when they can contribute to it. Okay, we'll have some small demo, but let's go ahead and can you still see my screen? I think I have to share my entire screen now. Can you still see my screen?
Yes, we can see it. Yeah.
Okay, so we'll be downloading some of the tools that we've mentioned. Just for the purpose of those, or for the sake of those who don't have any of this, let's just go through the process real quick, and then we'll come back and write some very, very basic codes to do some very basic stuff. Okay. Right, so let's look at which one should we do first? Let's look at Python. Okay. Now, Python, you can go to, just type Python download or download Python. Right. So I wish that you'll be following those who don't have Python already. They are doing this for your sake. So you come here, you see Python, the one from python.org. You click on it, and then it takes you to this Python download page. Okay, so you download, you can download the latest version of Python to be on the safer side. There are different versions that you can download. But just go ahead and download whichever is suggested for you. And we have different Python versions for different operating systems. So if you're on Windows, make sure the Windows is selected for you. If you're on Linux or Mac, make sure the same is selected for you. Of course, we have other ones which are outside the scope of this class, using Docker. Those who do containerization and all that, you can download your Docker version. Right, let's just download it. It's a simple thing, so you just do and it's downloaded. Right, now once it's downloaded, just click on it to open, or go to the Explorer and then double click it to install. I already have Python. That's why it is giving me this. I already have a different version there. So if you don't have, it should tell you, it shouldn't tell you to upgrade. It should just tell you to go ahead and install. So you can go ahead, click on the installation. Now you may be given an option or an interface where it tells you to add to path. Make sure you check that. Okay, check it. Make sure you've selected that part, that add to path. That will help you run your Python from anywhere on your PC. Okay. Please, is someone trying this? Is it working for you? If there are a problem, let's help you solve it right now. Okay.
National soccer team, the Black Stars of Ghana, head coach Ocho Ado has also released a squad that will be helping Ghana in our final 2 games.
Like your side.
World Cup qualifiers. What?
If you're not asking questions, try and mute yourself. Someone is talking. Thank you very much. Right, so I believe everyone, we are on the same page on the Python. So let's go ahead and look at the other ones. We can download a Git. So you can just say maybe download Git. Right, so the list, the link comes for you, and then you click on it to download. It's as simple as that. You download whichever, for whichever operating system you are using. I'm on Windows, so I'll use this one. If you're on Mac, go with this. Linux, go with this. Okay. All right, so you can decide which version you want to download, and then it downloads for you. Okay, and once it's done, just double click on it to install. If you meet any weird interface I don't understand, just let us know so that we help you resolve it. Any problems so far?
Yes, I lost connection a little bit. So can you give me what we are downloading? The Gates, right?
Yes, so we are downloading some of the tools that will be needed. We did for Python. We also downloaded which one was that? Yeah, okay, Python was the first one and Git is the second one.
Okay.
I have a comment. Is it possible for us to have a list of tools that should be downloaded before a session like this so that we
Yeah, I get it. It's also part of the school, right? To show, it's not everyone that comes from a tech background. So it's all part of the school. We've calculated it into the time.
Oh, okay. So I was bringing it up because, I mean, we all have, some have different download speeds. Some may encounter certain challenges, but if there is that kind of pre-information that, okay, download this tool with maybe resources, whether go to YouTube, watch someone do it, etc. Yeah, that. So it's just a suggestion. I didn't know you have factored it into the time for today.
Yes,
yeah, but that is.
Thank you very much. I mean, when you start the main class, they won't be adding all of these things into the lesson. Okay, this is introductory, meant to give you the very basics of what you are going to see. That's why we factored it into this time, but it won't be factored into the main teaching time. Okay. We have Git. We can do maybe 2 more or 1.
Hello. Please, can you take me through the process again for downloading Git?
Okay. Are you able to get this page?
Yes, please.
So if you can get this page, it's here. The versions are here. Okay, you can decide whichever version you want to use for your PC. Mostly click on the here to download. It will give you the most optimal for your PC. Or you can click on the 64-bit one.
Thank you.
You're welcome. Okay, so you also want to download R and R Studio. So R is the language, and then the R Studio is the IDE you use to write the R. So just like Python is the programming language, and VS Code is the IDE. That is how R and R Studio works. So you can say R, download R. Right, you see this R, and then you can go ahead and download R version 4.5.1 for Windows, and then it will download here for you. Now, I've already downloaded it before, and so I will just install it from my old download for us to see how it looks like. And then let's download the R Studio.
Hi, Prince. Do we have for Mac? I can't see Mac.
Is it R? I think we should.
Yeah, R. Because I'm not seeing it there. So.
Are you looking on my screen or your screen?
Your screen?
Sometimes when you log in, when you access a site, it picks your operating system by default and shows you that one.
Okay,
so
let me.
You may have to try with yours.
Sure.
But the way R is popular, I think it should be on all the operating systems. Okay, so R Studio, right. Okay. Now you come to the R Studio platform website, and you see the installations. In fact, when you come here, they will give you for R and then the R Studio. You have all the links here to download. So here we want to download R Studio because we've already downloaded R. So R Studio, and it's also downloading. Like I said earlier, I've already downloaded them. So let's go ahead and install. So assuming that you've now acquired your R and your R Studio, so we install R. Yes, go ahead and accept. Yes, English. Ish, what did I do? Okay. Yes. Accept. Next.
So where can I install the R Studio? Is it the same website or?
Yeah, the same website. So after the class, one of you should send me a WhatsApp message. I'll compile the list and then I'll send to you. But I'll share today's slide with you so that you can look on the tools listed there and you can download them. So we have the R Studio, and make sure everything is checked, and then just go ahead and accept all the default settings. No, accept default, yes. Yes, and then you can go ahead and install. Now, once it's installed, you go ahead and then install your R Studio, which is what you'll be writing or where you'll be writing the code. This is just the engine that runs the R code for you. Finish. Then you go ahead and install your RStudio itself. Yes. Go to next. Make sure everything is checked. So for R, you need 1.1 gig of space to be able to install it. I will not go ahead and install it because it's going to put my PC in danger. I forgot to remove some files before doing it. I think I already installed earlier. If I install, I'm going to be left with just 200 megabytes, which is very dangerous for my PC. But go ahead and install it. I'm sure you have a lot of space on your PC. So go ahead and install it. I have to delete some things first. Okay. Now let's, I think we have a number of them. That's good. Let's go ahead and set up Jupyter in our VS Code using Python. Okay. These are all test files I was using to prepare for the class. Maybe just a glance. Look at how interesting it looks like and how it's
Sorry to cut you in. Prince. Can you share these files with us?
Yes, they are for you. Once we are done, you have everything. I prepared them for you. Yes, I want you to see some of the, you see how nicely you can use the Python code in Jupyter Notebook in VS Code to generate some of these images. You can copy them, you can save. There are different kinds of plots. We'll be doing all of this real time for you to see how it works. We'll do all of these things. And all these charts, they have meanings. As you go deeper, you understand all of them. Right. So let's go ahead. Let's start afresh. Maybe I have
Prince, quick one. Oh, sorry.
Right.
My internet went off briefly. The R, you said we should
Please,
install the
who
R
is
Studio.
writing on my screen?
The R, you said we should install the R Studio, right?
Upright.
Yes, R and RStudio.
We should install both. Okay. Thank you, sir.
So R is the language and RStudio is the IDE. Okay. Right, now let's go ahead. Let's open a fresh VS Code. Now we can also see my VS Code. How do I clean these annotations that we have done? Okay. Good. Okay. Okay, all right. Now, you need to install a couple of things to be able to run your Jupyter in VS Code. So you start with Python. If this is the first time you are setting up your PC, you need a Python extension for VS Code. This will help you run Python. It will give you things like the IntelliSense and syntax highlighting and so on. So you can type for Python. Type Python in the extension marketplace, and you're looking for the main Python. The main Python, the one from Microsoft. Now, that one comes with other packages. It comes bundled together with other packages that will help you. So it comes with Pylance, it comes with Python debugger. That is this Python debugger. This is the Pylance. Right now,